All right, let's do some polynomial division. So we have three examples here, and for each one, we're going to do two methods. That's synthetic division and polynomial long division. What you're going to find after we do these three is that synthetic division looks and seems a lot easier than long division. And for the most part, that's probably true. However, we're a little bit limited on when we can use synthetic division. Specifically, we can't do it when we have a binomial with a degree higher than 1. So we have to have a linear term. So it's fine if we divide by x minus 2 like we do in part A, but you can't divide by something like x squared minus 2 or x to the fifth minus 2. It has to be linear. It can have a coefficient in the front, but it has to be linear. Now let's get to this. So the first thing for synthetic division is going to be you're going to want to find out what we're dividing by. So x minus 2 is a factor. We want to know then what is the root? What is the x-intercept? So you can add 2 to both sides and you get x equals 2. So we're going to set up 2 in a little box here. And starting at that 2, we're going to start writing the coefficients of the polynomial from the top. So we have 2x cubed minus 5x squared plus 3x plus 7. You don't really have to put the pluses, but I'm going to put there just to be thorough. And put a long line down here. We're going to want essentially want to make a box out of the last term. So step 1, bring down the first coefficient 2. The next step is we're going to multiply whatever we've got at the bottom times the number in the top left. So we multiply 2 times 2 and we get 4. And that'll go here. And now we just do some addition. Negative 5 plus 4, that's negative 1. Multiply again the number we have times the number from the top left. So negative 1 times 2, negative 2. 3 minus 2 gives us 1. We again multiply 2 times 1, gets 2, and 7 plus 2 is 9. So we've got these numbers that essentially make up our remainder and our quotient. Our quotient being right here, and our remainder being right here. But we need a format. So the number in the box is your remainder. So that's a plus 9 over the number that you're dividing by, or sorry, the polynomial, so x minus 2. The rest is going to be the standard polynomial form. So starting from the 1, that's the constant term, so we have plus 1. The negative 1 is the linear term, so negative x. And the 2 is the squared term, or the quadratic term, so you have 2x squared. And the next one would be the cube, the fourth, the fifth, so on and so forth until you run out of space. And so here we have our solution for 2x cubed minus 5x squared plus 3x plus 7 divided by x minus 2 is this 2x squared minus x plus 1 plus 9 over x minus 2. Synthetic division, pretty simple, just bringing numbers and multiplying, addition and multiplication over and over again. Now let's do long division. That's going to give us the exact same solution. It's just going to be a little bit different how we do that. So just like you would in real long division, or regular, we can put our top polynomial in this case inside our division. And the number we're dividing by, or the polynomial in this case, goes on the outside, right here. And if you recall from long division, we're always checking to see how many times the number you're dividing by goes into the number we're trying to divide. And in this case, we have something pretty similar, but we're matching up the leading term of the x minus 2 to the leading term of 2x cubed minus 5x squared, so on and so forth. So what do we multiply x by to get 2x cubed is the question. And what we multiply that by is x squared, so that we get the right exponent, and a 2, so we have the right coefficient. So x times 2x squared is 2x cubed. So I'm going to put 2x squared up here above the squared term. And now, as we do in long division, you want to multiply what you just found times the number you're dividing by. So we're going to multiply 2x cubed 2x squared times x minus 2. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. And as in division, long division, we want to subtract this. And if we're going to subtract this, we're subtracting the whole thing. So for the case of a polynomial, we're going to need to distribute the negative inside. So the negative times the 2x cubed gets us negative 2x cubed. And the negative times negative 4x squared gets you positive 4x squared. So now we have a negative and a positive here. And we're just going to do some addition. 2x cubed minus 2x cubed, just 0, goes away. 5x squared, negative 5x squared, plus 4x squared is negative x squared. And from there, we can bring down the rest of the polynomial. Plus 3x plus 7. And we repeat the process again. To get negative x squared, we multiply x by negative x. So that's going to go at the top right there. X times negative x is negative x squared. Negative 2 times negative x is positive 2x. And again, we want to distribute a negative in. So the negative x squared now becomes a positive x squared. And the positive 2x now becomes a negative 2x. Negative x squared plus x squared, 0. Positive 3x minus 2x is x. And we bring down the 7, and we have plus 7. And what do you multiply x by to get x? Just 1, positive 1. X times 1 is x. Negative 2 times 1 is negative 2. And we combine. Distribute in the negative. You have negative x, positive 2. X minus x is 0. Positive 7 plus positive 2 is 9. And again, we end up with our quotient up here at the top and our remainder here at the bottom, which exactly matches what we have here, because we have 2x squared minus x plus 1 in the quotient, and for the remainder of 9, we're just going to put it above that divisor of x minus 2. So we get the same solution from both methods. It was a little easier to run synthetic division. Luckily, we could use it in this case. If we couldn't, we would have to do the long division. So let's try another example. The next one, 2x cubed plus 5x squared plus 9. The key thing to notice here is that it's in standard form, but it's missing a term. Part A was in standard form, and it had a cube term, a squared term, a linear term, and a constant. This one has a cube term, a square term, no linear term, and a constant. That's something that we're going to have to deal with for the sake of synthetic and long division. We're going to have to put a placeholder there. But let's start with finding out what our x-intercept or our root is, rather, in this case. So take x plus 3 and set it equal to 0. Subtract the 3 from both sides, and you get x equals negative 3. So we're going to divide the negative 3. And our polynomial is 2x cubed plus 5x squared. There is no linear x term. So we're just going to put a 0 there. And then the 9 for constant term. So we put that 0 there to take place, to keep a placeholder for the missing x term, which is very important. Without it, we're not going to get the correct solution. So bring the 2 down. Multiply negative 3 times 2, you get negative 6. 5 minus 6 is negative 1. Negative 3 times negative 1 is positive 3. Negative 3 times 3. I'm sorry, we have to do the addition first. 0 plus 3 is 3. Negative 3 times 3 is negative 9. And then when we add 9 and negative 9, or subtract 9, we get 0. So in this case, we have no remainder. There's no remainder present in this one. So we have no remainder. And we have quotient right there. And just as we did before, we can say that we can put a plus 0 over x plus 3, which is essentially 0. We can put our constant term of a 3, our linear term negative 1, so negative 1x, and our squared term 2x squared. So that is our solution. Interesting things about this. If there's no remainder, that makes x plus 3 a factor of the top polynomial, which is really important and really what we're going to be using synthetic division for finding factors in any scenario. So we could write this if we wanted to as 2x squared minus x plus 3 times x plus 3 being equivalent to the polynomial at the top, which I'll even go ahead and write. So we can say that 2x cubed plus 5x squared plus 9 is equal to 2x squared minus x plus 3 times x plus 3. That's essentially a factored form of this polynomial. But the quotient is the 2x squared minus x plus 3. Now let's do this with polynomial long division. So we're going to divide by x plus 3. We have 2x cubed plus 5x squared plus 0x. So again, that placeholder that we need, plus 9. So what do we multiply x by to get 2x cubed? Multiply by 2x squared. Multiply 2x squared times that binomial. 2x squared times x is 2x cubed. 2x squared times 3 is positive 6x squared. Distribute a negative. Negative 2x cubed minus 6x squared. We, of course, get 0 for the first part and negative x squared for the second part. Bring down the polynomial. We multiply x times negative x in order to get the negative x squared. You multiply negative x times x, you get negative x squared. Negative x times 3 is negative 3x. And factor in, or rather distribute the negative. You get positives all around. And so we get termination from the x squareds, and 0 plus 3x is 3x. So it's very important here that we keep that x term or put a placeholder for the x term, because we wouldn't have anywhere to add this 3x if we didn't. And we wouldn't have anywhere to put the negative x at the top if we didn't. So it's a good thing we have there. We bring down the 9. You multiply x by 3 in order to get the 3x. So you have 3x plus 9. And subtracting the same thing minus itself. But let's distribute the negatives in. We get negative 3x, negative 9, and all of that terminates. You get no remainder. So no remainder down here. And a quotient up here that matches that of the previous synthetic problem. So again, we have matching quotients. But it's very important that we put that 0 in so that we get the right quotients. All right, let's look at one more example on the next page. This is 3x cubed plus 5x minus 1. Again, we're going to need that placeholder in this case for the x squared term. Let's start with setting x plus 1 equal to 0. Subtracting 1 from both sides and getting x equals negative 1. So in the synthetic division, we have negative 1 in the box. 3x cubed plus 0x squared plus 5x minus 1. Big line across the bottom. And we'll just run through it very quickly. Bring down the 3. Multiply negative 1 and 3 to get negative 3. 0 minus 3 is negative 3. Negative 1 times negative 3 is positive 3. 5 plus 3 is 8. Negative 1 times 8 is negative 8. And together that adds up to negative 9. Just need to put my remainder box there. And so quotient and remainder. So we have minus 9 over x plus 1 as our remainder. And then we have positive 8, negative 3x, positive 3x squared. And over here on the remainder, we can put the negative in the numerator and put a plus, or as I'm going to do, we can just put a negative right there in front. So a subtraction symbol. And so here is our solution, our quotient and our remainder. Now let's do long division. Make sure we get the exact same thing. X plus 1 is dividing 3x cubed plus 0x squared plus 5x minus 1. You multiply x by 3x squared to get 3x cubed. Multiply it times x plus 1. You get 3x cubed plus 3x squared. And we're, of course, subtracting. So distribute the negatives. Getting rid of the x cubed terms. And 0x squared minus 3x squared is negative 3x squared. Bring down the rest of the polynomial. Get 5x minus 1. And in order to get negative 3x squared, we're going to multiply x by negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times 1 is negative 3x. Distribute our negatives gives us 2 positives. So I'll make a positive on the second one and erase the negative on the first one. X squared terms cancel out. 5x plus 3x is 8x. Bring down the negative 1. Multiply x by 8 to get 8x. So you're going to get 8x. 8 times 1 is positive 8. And we're going to distribute the negative in. Negative 8x. Negative 8. The 8x's cancel out, and you're left with negative 9. And just as before, on the last part, we have negative 9 as our remainder. And 3x squared minus 3x plus 8 as our quotient. So we're getting the exact same answer. So as we've seen from these 3 examples, you can get the same solution whether you do synthetic or long division. It's just very important that if you're going to use synthetic division, you have a linear binomial.